Welcome to Vitronauts, the space where we explore the universe of vitro. I am Ana Hernandez, your host. Today, we are joined by Adam Polcyn, SVP of Research and Development at Vitro Architectural Glass. In this episode, we will explore the innovations shaping the glass industry, key R&D breakthroughs, and what the future holds for the next 5 years. Stay tuned. Hello, Adam. It's so great to have you here as our guest in this season 2 of Vitronauts. And I would like for you to please introduce yourself to talk about what you do as a leader of the R&D department.
Sure. Thanks, Anna. So first of all, thank you so much for the opportunity. I'm really excited to be in the Vitronauts series and looking forward to our conversation. So yeah, I'm Adam Polcyn, Senior Vice President of Research and Development. I'm located in Pittsburgh at our Glass Technology Center. And so what I do is I lead our research and development organization, a group of about 60 to 65 people. And really what we're focused on is bringing sustainable competitive advantage to vitro. So through technology. So we develop new products and new processes using our expertise, and which I believe is really world class in the glass industry to develop new technology, new products, new processes that will give Vitro an advantage in the marketplace and help us to be more profitable and really to be leaders in the industry. So I've been with the company for almost 21 years now.
Wow.
And so started out with PPG and did a lot of work in the MSVD coatings area. So some of the solar band coatings. So solar band R100, solar band R67 are projects that I was involved with. I also did some work in MSVD coatings for the solar industry when we were doing that work. And then more recently, the past, I guess, 10 to 15 years or so, I've been doing more management roles. So I worked in managing R&D on the glass making process, the float technology process. And then I managed the MSVD team, which does the solar band product development. And then finally, I took my current role in 2019.
Wow, that sounds really, really interesting. And I believe sustainability and technology is a great, great combination. So why don't we start this conversation and let us begin with the first question. Considering the current needs of the architectural glass industry, which technological aspects should a research and development area prioritize when producing glass?
Yeah, that's a great question, Anna. There's a number of them and a lot that you could choose from. I think kind of one of the main areas is in value added glass products. So taking flat glass and adding value to it. So there's a number of different ways we do that today, and a number of different ways that we're looking at potentially doing that in the future. So what we do today primarily is add coatings to the glass. So MSVD coatings, the solar band product line, again, is a very well-known product line. Right now in Carlisle, we're working on also adding CVD coatings, which are actually deposited on the float line at very high temperatures, and doing that for our customer First Solar. So those coatings really help to improve the thermal performance of the glass. So making buildings cooler in the summertime and warmer in the wintertime. and so they help save energy, really, which is also very important. Um, that the value added coatings are also important in the solar industry and the automotive glass industry as well. There are other ways you can add value to glass as well. So another technology that's very interesting now is dynamic glass. So Vitro has invested in what's called PDLC technology. So that's a technology where you can press a button and a window can go from having a clear view to having a very hazy view that you can't see through at all. So to give some
Wow.
privacy, we're
Yes.
looking at that for automotive and architectural. Um, and there are other types of dynamic glass where you can basically, again, by pressing a button or controlling the window with an electrical signal, you can make the glass dark or clear, depending on how much sun is coming in to the building. Sort of like if you've ever seen the glasses that automatically get dark when they're out in the sunshine.
Yes.
Vision lenses. So not exactly the same technology. This is more, you have more control over it because the user has more control because they can use an electrical signal to activate it, but it has the same idea.
Wow.
So that's another one. And then finally, taking the glass and building devices with it. So, for example, uh, dynamic glass would be an example of that, but then also VIG or vacuum insulated glass, making a new type of window that's as has as much insulating value as a wall, which is also very, very good for energy efficiency in buildings, um, as well as decreasing sound and sound transmission into the buildings. So a lot of different ways of adding value to the glass, taking the glass, putting a coating on it, making it dynamic, putting it into a vacuum insulated window. So a couple other areas, if I have time, I could touch on.
Of course.
Uh, Process control technology and data analytics and artificial intelligence. These are all very important technologies that are obviously pretty cutting edge right now and that are important to help us decrease costs in our manufacturing operation, make us run more efficiently. And they also provide new capabilities. So they allow us to do things that we weren't able to do without those technologies. And then finally, I think I mentioned sustainability already, but going into the future, reducing carbon emissions, reducing our energy usage, those are very important areas for research, and because we believe that in the future they're going to be very important for our industry.
What you just explained sounds so, so interesting. And I bet you and your team have a lot of fun doing these research and development processes. And, one of our last episodes, we had Fabio Mercurio, which is in charge of the analytics and artificial intelligence in vitro. And he was actually explaining how AI helps detect certain imperfections during a flat glass manufacturing process.
Yes.
And it's so nice, so we can have this combination of technology and also sustainability. And it's also very, very interesting because when we read papers or on the news about these buildings, these architectural masterpieces, we think sustainability in within that goes within, I don't know, the use of concrete or less energy used to create the building. I'm sorry,
Sure. Sure.
but we never get to know what's going on with the glass, and you explaining what's going on within the process of glass and how glass contributes to sustainability is really, really, really interesting. Thank you for explaining this to us, Adam. So I'm gonna go to the next question, and is from your perspective, which five R&D breakthroughs, recently or highly influential, have had the greatest impact on the current state of glass production?
Well, yeah, that's an interesting question. I mean, there's so many things. The uh, the glass process is so technologically intensive and it's so varied in the types of technology that it requires, which is one of the things that I really love about it. That over the course of my career, I've been able to do work that would be more chemical engineering or physics or chemistry, or mechanical engineering, all kinds of different technology that's required to make the glass that we sell. But I guess if I wanted to narrow it down to five, so this one probably the first one, which is not particularly recent, but on the scale of glass making, I mean, humans have been making glass for thousands of years, right?
Right.
But uh, one of them one uh, innovation that was really key was the development of the float process. So the ability to take glass and pour it onto a bath of molten tin and
Yes.
form flat glass using the float process. So that was developed kind of in the 50s and 60s. So a long time ago for some of us, but in other ways, in the history of glass, actually very recent. That process really revolutionized glass making in general, making it much more efficient and lower cost, and also higher quality as well. So the previous after the float glass process was developed, within 20 years, the previous ways of making flat glass disappeared basically.
Mm,
So that was really the a very important breakthrough. Um, I guess another one I would point to is just the MSVD technology in general, the technology that goes into the solar band product line. So um, making specifically like a solar band 70 type glass, that was really sort of a benchmark where we were able to taking glass with solar band 70 on it reflects 99% or more of the solar infrared energy, the solar heat energy that's coming into a building from the sun. And with that milestone, that really made a big difference in the energy saving, the solar control capabilities of glass. Um, One kind of related technology there was the ability to make solar band coatings that could be tempered by our customers. So um, basically to make a coating, which it's a very fragile coating with very thin layers, layers of silver that are very delicate. And if you just take a very thin layer of silver and you put it on glass, and then you do what a lot of our customers do, which is temper the glass to make it stronger. What the tempering process does is it puts the glass at a very high temperature and then cools it very quickly. And
yes.
so if you if you just put silver on the glass and then did this, the silver would be completely destroyed. So it took many years, but and this was really pioneered by PPG to find a way of protecting the silver so that you could uh, deposit the coating on a very large piece of glass, then send it to a customer who could cut it to whatever size they needed the window to be, and then temper it, and then have the coating still survive and look good. So that
Right.
was really revolutionary, especially for at the time PPG and now for Vitro. In the architectural glass business, we have the Vitro Certified Network, which is our network of customers that have exclusive access to our solar band products. And if we didn't have that technology, that was really an enabling technology to allow us to really follow our current business model, which is to make large pieces of glass with coatings and then ship just those large pieces, all the same size, to our customers, and then let them do the final processing work. So that was really an important one too. Um, I guess I would also say, sort of the automation, all the automation that's gone into glass. So the ability to handle very large pieces of glass with robots, the ability to also detect defects on the glass with vision systems, sort of what Fabio was referring to. Um, that's also been very important technology and really revolutionized it. I mean, if you go back uh, to the earlier part of the 20th century, people were handling large pieces of glass. People were doing,
Correct.
which is not safe and is also very difficult work. So there, that was a really a big step forward. And I guess finally, I would say the insulated glass unit technology. So the ability to make a window that has two pieces of glass with a solar band coating on the inside and a seal kind of between those two pieces to kind of control the atmosphere and the environment inside the window so that the solar band coating can last for a very, very long time. And then also give you the additional insulating value and energy efficiency that you get from that. So I think those technologies, really the float process, the sputtered coating process, the automation, the process control, the robotics, and then the window insulating glass unit technology. Those are, in my mind, at least, just thinking informally, those are kind of some of the really key breakthroughs in recent times that have really formed our industry.
Wow, it's also really interesting, and you were just mentioning that you pour some silver in the glass. I just picture how someone would work this process, but with metals, and working with metals. It's so different than working with glass. And one would think that glass is such a delicate material, but as as you were explaining and describing all the process, I think that glass is also really strong because of all the process it goes through and so flexible. And that
Yes.
is really, really amazing.
Yes. No, glass is an amazing material. It is very, very strong, intrinsically very, very strong. And a lot of the reason it breaks tends to be related to cracks and little defects that are formed in the surface. And it's very, very strong when you try to compress it. In tension, it's not as strong, but yeah, very, very strong material. Will put up with a lot. And actually, I should probably mention, so I don't mislead our listeners. So when the silver is deposited in the solar bin, it's actually deposited inside a vacuum chamber at very high vacuum. So there's no air inside of it, and there's a solid block of silver that's used. And we use a certain process that uses electricity to basically and a little bit of a argon gas inside the chamber to basically knock the silver off of that block of metal, that block of silver. So these little argon atoms or argon ions actually
Yes.
sort of knock against the silver and release silver atoms that come down and fall on the glass. And so it's really amazing to me that it works at all. But using that process, we can get layers of silver that are uniform to within maybe one atom of silver, one or two atoms of silver across a jumbo piece of glass, which is 130 inches. So very, very uniform, very good process.
Yes, and there's a lot of chemistry going on within the process, uh, getting the glass to be coated as well as other materials,
Yes, yes,
and it's a really amazing process.
yes.
So we're gonna go through our last question, and it would be, where is the research and development area headed in the next 5 years?
Yeah, so I'll tell you what I think, but we can't go and look back at this interview in 5 years and see if I was right or wrong. But
It's
and I guess
okay.
that's kind
We
of my
won't.
first point is that we certainly have a strategy and we certainly have our ideas of where the technology is going, and it's really our goal to uh, uh, to develop and understand the science well enough that we can define what that future will be, right? But we also want to be flexible and adapt to whatever happens in the world. So in terms of the directions that we're going, I would see more focus on solar glass for the solar industry. So
Mhm.
as you know, we've signed a couple of long-term contracts to supply First Solar with glass, fabricated glass, and coated glass for their business. And I see the solar technology that First Solar is developing and others in the business um, developing and changing over the next 5 years. And we want to continue to be in that area and developing new things so that we can go to our customers and have the latest and the best glass technology for them to incorporate into their solar panels. So that's one area. Um, I think I think sustainability of our glass making process is going to be important over the next 5, maybe even longer term, 10 years. Um, I think that carbon getting to a carbon neutral process is going to be more and more important, and so we're pursuing some projects related to that right now as well. I mentioned dynamic glass before, where you know you can uh, you can control visibility through the glass using electricity or some other means.
Yes.
We're going to continue looking at that. I mean, there's been some kind of early products in that area, but so far none of them have really taken off that much, and so we're going to continue looking at that possibility and whether we can come up with a solution that will be more accepted in the market and more profitable for Vitro. And we talked about AI before, so I think artificial intelligence, data analytics, and control using AI to help control our processes, as well as other advanced process control methods. We're going to continue focusing and pushing on that. I think that's really changing a lot of parts of our world, and it's going to change the glass industry as well. And then finally, we talked about vacuum insulating glass a little bit, but I see that as a really something that's going to grow. And with the focus on energy savings and energy efficiency in buildings, that's really a great product, and it includes our solar bank coatings. So I really see us trying to develop in that area as well.
Thank you very much, Adam. And I know that was our last question, but I would like to ask one last question.
Sure,
And
of course.
what do you enjoy the most at your position? Because we have talked about the chemistry within the process, we've talked about technology and sustainability. You have talked about from your position at PPG and then Vitro. We've we have talked about a lot of technology involving the process. So, which part do you enjoy the most? I know there can
You're
be a
kind of
lot.
asking me which of my children do I like the most. I don't know. That's a
Kind
hard.
of.
I mean, uh, I'll say again, I really love the glass technology because of the wide variety of technology that's involved in it. And I think probably if you ask me what I like most about my job, it's really working with other scientists. Honestly, I mean, I think working and not just with other scientists, but so the other scientists in R&D, my colleagues, I really appreciate them and working with them, and also seeing them grow and achieve things. I also appreciate working with my colleagues in other parts of the business. So the operations folks, I really enjoy being in the factories and working with them and seeing what their challenges are and trying to help with those. Um, the marketing colleagues, I enjoy finding out what's going on in the market and trying to think about how can we as R&D really contribute to that and really help make a difference in the marketplace. And that's for our sales colleagues as well, and supply chain as well. Actually, we're starting to do some projects, data analytics and AI related projects in supply chain, and I think that's an area that we'll start to see growing as well, using technology we've developed and applying it in other parts of the business. So I think really my favorite part is the variety of people that I get to work with, and
Yes.
my colleagues who are very motivated and excited about technology as well, and then also having the opportunity to make an impact on all the different aspects of technology and glass. So I'm not sure if I'm answering your question, but
Yes, you are.
that's fine. Yeah.
Yes, you are. As a position that connects and communicates with a lot of areas of the organization, I would answer the same as you did, the same as you did.
Yeah.
So,
I guess, yeah, I guess I would also say I just want to emphasize also one of the things I really like about Vitro is that we also are a multinational company, right? So
Yes.
I have colleagues in the US, I have colleagues in Mexico. I can practice my Spanish with my colleagues in Mexico sometimes, and
That's
I
great.
I also really enjoy that aspect of
Uh,
working for Vitro. So yeah.
oh, that's so nice. We can change the conversation in Spanish actually if you would like. Thank you, Adam, for sharing your insights and experience with us.
Thank you so much, Hannah. Really enjoyed it.
It's been a pleasure having you on Vitronauts. We hope to have you back with us in a future episode.